Everyone, this is Hemalatha from Marri Reddy Institute of Technology and Management. I have been working in this institute as an associate professor in the Department of Physics. Now today I'm going to discuss you about the Applied Physics Laboratory. The Applied Physics Laboratory, which is having 12 experiments which are being designed by JNTU as per the syllabus. Now, the first experiment regarding the first chapter, which will be dealing with the quantum mechanics, where we are having the photoelectric effect, in which we will be working about the determination of calculation of the Planck's constant using photoelectric effect. Now, the second experiment is related to semiconductors, that is how we are going to determine the carrier concentration of Hall effect. That is, for a given semiconducting material, we are going to find out the Hall coefficient. That is the second experiment. Third experiment is regarding the LCR series and parallel circuits. We have to study about the characteristics of LCR series and parallel circuits, where we will be calculating the resonant frequency and the bandwidth and the quality factor of the given circuit. Next, we have the fourth experiment, that is regarding the semiconductors, that is the VI characteristics of PN junction and the Zener diode. Here we study about the variation of voltage, how the variation of voltage is taking place and how the change in current is taking place will be studied in different diodes like PN junction diode and the Zener diode. And the fifth experiment is the same semiconductors, that is the BJT, bipolar junction transistor. In this experiment, we study about the input characteristics and the output characteristics of BJT by maintaining constant base voltage and by maintaining constant collector voltage. What are the input and output characteristics of BJT? We'll be studying in this experiment. The sixth experiment is regarding the LED and laser, which is an optoelectronic device. For this optoelectronic device, we study about the variation of voltage and the variation of current. And not only this variation of voltage and current, we also study about the power and I, the change in the power with respect to the current. That also we studied in this one. That is regarding with respect to LED and laser. We study about these two things. Next, coming to the next experiment, that is we will study about the solar cell, which is also one of the optoelectronic device. We study in the solar cell the VI characteristics. Next, eighth experiment is energy gap of a semiconductor. Already, as you have come across the semiconductor topics, where you will be studying about the valence band and the conduction band, and in between these two bands a gap is existing, that we call it as the energy gap. And how the energy gap of a semiconductor is present, that we will be studying about in this experiment. Next, ninth experiment is the RC circuit, the variation of time constant. How do the variation of charging and discharging using an RC circuit takes place, that we will be studying in this experiment. 10th experiment is optical fiber, that is we are going to determine the numerical aperture and acceptance angle of a given optical fiber. And the last experiment, that is the 11th experiment, understanding the method of least squares. One of the example which they have given us is to go with respect to the torsional pendulum. In this torsional pendulum, we calculate the eta, that is the rigidity modulus. Later, we calculate the method of by using the method of least squares. What are the errors present in this one? We will be calculating. And the last experiment is determination of magnetic field induction along the axis of a given current coil carrying conductor. That is by using Stewart's and Wies experiment. This comes under the magnetic materials, where we study about the magnetic induction and by using the Biot-Savart's law, how the variation is taking place at different points will be done in case of this experiment. So this is a brief introduction about the list of the experiments which are there in this applied physics laboratory. Now today, coming to my topic is I'm going to explain about the RC time constant, that is by using R and C. First, initially, what is R? R is called as a resistor. Then what is a resistor? A resistor is nothing but which opposes the flow of electrons. When you apply current, when you apply a voltage on a given circuit, then automatically the motion of electrons takes place. Now, if this motion of electrons is taking place, then the opposition, that means the traveling of electrons in opposite direction with respect to the applied field, we call it as, we define it in terms of resistance. So we define a resistor or a resistance as the opposition of flow of electrons, and the units of this resistance are designated as ohms. Then the next component is C. What is C? C is called as an capacitor. Now, what is a capacitor? A capacitor is nothing but a device which is used to store energy. Now, every day in the morning session, what we do? We charge our cell phone. A cell phone is having a battery. A battery is nothing but it works as a capacitor. So, a capacitor is nothing but a device which is used to store the charge. Okay, so by storing the energy in the capacitor, we study the time constant in this experiment. Okay, the units of resistor, as I told you, it is ohms, and the units of capacitor are farads. This is the experiment which I'm going to explain you about in this class. Next, for every experiment, you have to find out, basically give what is the aim. Aim in the sense is nothing but what you are going to find out, what you are going to determine, that you need to tell. That we call it as aim. Now, coming to this experiment, aim is nothing but to study the charging and discharging of voltage in an RC circuit containing resistance and capacitor, and compare the experimental RC time constant with theoretical time constant. Here in this experiment, we also calculate the RC time constant in a theoretical process also. How do we calculate that one? In the next part, I'll tell you. Now, what are the apparatus required? We are going to do an experiment. So, when you are going to do an experiment, we require some apparatus. So, to do this RC experiment, what are the apparatus required? One power supply. We require different types of resistance values. Then we require capacitors, different types of capacitors. We want an voltmeter to show the voltage. Then we want a stop clock. Why we want a stop clock is to record the time. Next, we got a connecting wires. These are the components, apparatus which are required to carry this experiment. Next, what is the principle of this experiment? As we have seen in the aim of the experiment, we are going to study about the charging and discharging. So, what is charging first? What is charging time constant? Now, we define the charging time constant as the time taken by the capacitor. The time taken by the capacitor to charge to 64% of its initial value. Now, the amount of time taken by the capacitor to charge to 64%, that is called as charging time constant. Now, general example I'll tell you. In the morning itself, we start charging our cell phone. So, initially it is 0. The charge is 0. When you start charging that one, it records some current, it records some voltage. That is nothing but energy stored in the battery. Now, if the charge which is stored in the battery is up to 64%, so how much amount of time is taken by the capacitor to attain the 64% of its initial value? That we call it as the charging time constant. Okay, next, what is discharging? Now, we have charged our capacitor, we have charged our cell phone from 0 to 100 it became. Now, we go for the next thing is discharging. What is discharging? Now, we start using our cell phone. When you start using our cell phone, automatically the charge gets decayed. That is, it gets discharged. So, the time taken by the capacitor to discharge to 37% of its initial value. That means once we start using the phone, then automatically the battery is getting discharged. So, the time taken by the capacitor to discharge to 37%, that we call it as the discharging time constant. Now, see in this charging, we are coming from 0 to 100. Now, in the similar fashion, discharging from 100 to 0 we will go. So, this is what we call it as the charging time constant and discharging time constant. Now, what is the principle? While that is in terms of the equations, we write the charging voltage which is generated across the capacitor is given by the general equation V is equal to V naught into 1 minus e power minus t by RC. Now, what is this V? V is the voltage which you are applying. What is this V naught? V naught is a maximum voltage which is generated in the capacitor, maximum voltage where the capacitor is capable of. Then minus T, T is called as the time constant. R is the resistance, how much value of resistance you are using. C is the capacitance, capacitor which you are using, it has a certain value. What is that value? If you substitute all these values in this equation, you will get V is equal to 64%. That is called as charging time constant. Similarly, for discharging time constant, that is V represented as V is equal to V naught e power minus t by RC. Now, V is equal to V naught. V naught is a maximum value which is stored inside the capacitor, that is V naught. T, time constant. R is the capacitor value, what you are using. C is how much capacitance you are using in order to produce an voltage of, in order to get decayed it to 37%. If you substitute all these values in the equation, you will get 37%. That is called as the discharging time constant. Okay, next. Now, in order to go with respect to the experimental process, we have a circuit diagram. Now, the circuit diagram is a simple circuit diagram. This is a voltage source. We have to supply some voltage. Then it is connected to a switch. Switch is nothing but an indicator. That means whether you are doing charging or discharging by using the switch. If the switch is on, we say it is charging. If the switch is off, we say it is discharging. Then we are using a resistor value here, how much amount of resistance you are using. Then it is connected to a capacitor, how much capacitance you are using in this one. Then you are getting it recorded in the voltmeter, that is how much amount of voltage is generated when the capacitor is getting charged. These two are connected in parallel with respect to each other. So this is the simple circuit diagram for an RC charging and discharging time constant. Very simple diagram this is. Next, now once you start doing this experiment, then after giving the connections, then what we do is initially we note down the values of R and C. Initially we note down the values of R and C. Now before going to the tabular column, let us see what is the procedure involved in this one. Now charging. Now when the terminal is connected to charging switch, so before going to this charging, we have to select the values of R and C. What value of resistance you are using and what value of capacitance you are using. You have to note down these two values on the top of your tabular column. Then after noting down what is happening inside the circuit, you have switched on the switch. Once when you switch on the switch, automatically the capacitor gets charging. When the capacitor gets charging, then note down for 1 minute, let us take 1 minute of duration of time. In 1 minute duration of time, how much voltage is generated across the capacitor? Then 2 minutes, how much? Like that till 10 minutes. Let us assume for 10 minutes we are taking the capacitor. How much amount of charging is taken in that capacitor? Let us take for 10 minutes. Then at the 10th minute, how much voltage is generated? That voltage we are calling it as the maximum voltage. And that maximum voltage value you need to substitute in the charging time constant equation. Now you started your experiment. When you start your experiment, we have switched on. After giving the connections, you have switched on. Then once when you switch on, see that the switch is in on condition. On condition means when the switch is on, we call it as charging. Now the circuit started charging. The circuit started charging is nothing but the capacitor started its charge. Now initially at 1 minute of time, how much capacitor, that is how much energy is stored in the capacitor, let us find out in terms of voltage. Then 2 minutes. Like that till 10 minutes, you record how much amount of voltage is stored inside the capacitor in terms of voltage. Then at that 10th minute of time, let us assume the voltage which is generated is called as the maximum voltage. Let us represent that maximum voltage by V0. And this V0 value you utilize in this charging equation and substitute the R and C values which you have utilized. Then you will get the value of voltage, that is the charging voltage, that is nothing but the 64% value you will be getting. Now you have completed the charging. Then the switch you make it into off condition. When the switch is in off condition, it is nothing but discharging is taking place. Discharging means how the voltage is getting reduced. We should note down that discharge. Again, let us take for 1 minute of time how the voltage is getting discharged. Then till 10 minutes of time, the voltage, let us note down the voltage values for 10 minutes of time. For every 1 minute duration, let us note down. Now the 1 minute time, for 1 minute of time, how much amount of voltage is generated? That is the maximum voltage, because here charging is from 0 to 100. Discharging is from 100 to 0. So at the 1 minute of time in the discharging mode, this for 1 minute of time, the value of voltage which is obtained is called as a maximum voltage. Now take down this maximum voltage and substitute in the discharging voltage equation in place of V0 and substitute the R and C values. Then you will be getting that V is equal to 37%. Then again similarly carry the experiment till 10 minutes. Then after noting down the readings for both charging and discharging mode, draw a graph for charging, that is time versus voltage. Here I have indicated as charge. Charge is nothing but voltage. Same thing. Now time versus voltage, time on x-axis, voltage on y-axis. And if you see the graph, as that is, we are saying that the capacitor is getting charged. Then charging in the sense is it started increasing from 0 to 100. So this is how the graph gets increased. Now similarly, if you plot a graph for this one, that is for discharging, that is from 100 to 0, we have charged and we started utilizing that battery. When you start utilizing that battery, it gets a decayed, that is discharge. So here the graph representation will be like this. That means from the maximum value to the minimum value it will come. This is from minimum value to maximum value it goes. Now put aside these two things after plotting the graph. What you need to do is you have noted down the values of R and C on the top of your tabular column. Now I'll show you the tabular column. This is the simple tabular column. Note down the values of R, note down the values of C. For example, I'm taking the value of R is equal to 56 kilo ohms. I'm taking the value of C is something around about 4,700 microfarads. Now, I have to determine the time constant. In order to determine the time constant, the formula is T is equal to R cross C. Time constant is defined as the product of R and C, that is the resistance, how much you are using, multiplied by the capacitor value. That will give you the time constant. T is equal to R and C. Now, use these two values, that is 56 kilo ohms. Kilo means 10 cube. Next, 4,700. Micro means 10 power minus 6. Now, you can see here 3, 2, 5 and minus 6. So, you will be getting T is equal to 56 into 47 into 10 power minus 1. Okay, now if you calculate this one, approximately it will be coming around about 263.2 seconds. This is called as the theoretical time constant. By using the values of R and C, which you are using on the experiment for doing the experiment, find out the theoretical time constant. This is the approximate value which you will be getting. Put aside. Then conclude the experiment. After conducting the experiment, draw the graph. Then note down on the graph. Then after this one, you take charging. Go for charging. We have to get the graphical value of time constant in charging and discharging. How to get the graphical value of charging and discharging? We said 64%. Then in the charging mode, let us take it as 0.64 into the maximum value, that is 1, 2, 3 up to 10 we have noted down. In this 10, I told you this is the maximum value. So this maximum value you need to multiply with this one. You will get the sum value of this one. Now similarly come for discharging. For discharging, what we'll do is the same, 1, 2 up to 10. Now this is the maximum value. It started with 0, ended with 100. Now it started with 100, it is ended with 0. Now let us take this value as V0, maximum value. In case of discharging, it is 0.37, it is 37%. So 0.37 into the maximum value, you put aside these two values. Then we have plotted the graph. Then in this graph, this is the circuit for graphical representation for charging, and this is the graphical representation for discharging. This is increasing, this is decreasing. Now whatever the value of charging you got, indicate on this one, indicate on y-axis, that is with respect to voltage, drag the line onto x-axis. This particular value where you have dragged onto the time, that value, for example, let us take it as something we are getting around about 230 seconds. Now similarly, the discharging value, which you have taken it for 37.37 into the maximum value of discharging. Let us take this is the value which you are getting. Let us think this is around about 210 seconds. This is 230 seconds, this is 210 seconds. Now see here, we have calculated according to the theoretical time constant, it is 263.2 seconds. Now coming to this one, you are getting in this one 230 seconds. In this discharging, you are getting 210 seconds. Approximately these two values are same with this one. This is how we can experimentally and theoretically verify the time constant in case of this RC circuit. Now what are the applications of this one? Now the applications are, these are basically used in timing and oscillators. What is this timing circuit? RC circuits can be used in timing applications where they determine the time delay between the signal changes. Now for example, let us take the traffic signal. There will be delay between red color, green color and orange color. To display the change, we use the RC circuit, that is a timing circuit. Next, oscillator. RC circuits can be used to create oscillators that generate periodic waveforms, typically in the combination with other components. They are used in clocks, radio frequency circuits, and audio generators. Now, the normal clocks which are utilized in our daily life, that is nothing but an oscillator. So, in that oscillator, the application which is used is nothing but, that is the signal, the delay in time or the time increase will be calculated by using this RC time constant. Next, analog computation, one of the application. RC circuits are sometimes used in analog computers for solving differential equations or performing mathematical operations, since they can stimulate the behavior of integrators or differentiators. RC circuits, they are often called as integrators and differentiators because they can integrate by using some other components. With a combination of R and C, we can use it in an integrator circuit and also in a differentiator circuit. Mostly this is used in electronic devices. So that's one of the application, analog computation application. Now finally we are getting the theoretical value. Here you need to note down, that is we have got 263.2 seconds, and the experimental value of time constant in charging mode we have got 230 seconds. In the discharging mode we have got 210 seconds. Now you can see approximately all are in the one range only, 263, 230 seconds, 210 seconds. Now you may get it out. This is 263, this is 230. Now, what the thing is, this is the time constant by using the theoretical values. This is the time constant by doing the experiment. So, there will be some errors which will be occurred in the experiment. So, due to that errors, there is a change in the experimental and the theoretical value. So, that does not bother here because we are doing experiment. So, we should not get the exact value as that of the theoretical constant. If you are doing that one, we say that you are manipulating that one. So this is about the experiment, RC time constant, and the book which has been prescribed by all the Applied Physics Laboratory Manual, which you will be using, is by S. Balasubramanian and M. N. Srinivasan, a textbook of practical physics by S. Chand Publishers. In this book, all the 12 experiments are covered. Not only these 12 experiments, 2 more experiments are covered in this one also. So this is the book which you can refer as a reference book. Okay, with this, I conclude my this experiment, RC time constant. Thank you.